Hello students, today in engineering chemistry we are going to discuss about the topic that is zeolite process. You know very well that hardness is present in water, and if this hard water is used in various type of industries, especially in boilers, then it causes a lot amount of boiler troubles. So in order to avoid these boiler troubles, we have one simple option that we can use softened water. Now how this water could be softened. So in our previous classes we have discussed about lime soda process, that is a good process for softening the water. Another good process is zeolite process, that is also used to soften the water. So today we are going to discuss about zeolite process, a water softening process. Now what are zeolites? Zeolites are hydrated sodium aluminosilicates, and these zeolites are also known as permuted. Okay, so this zeolite process is also known as permuted process. Now a very interesting property or capability that zeolites possess is exchanging reversibly their sodium ions with the calcium and magnesium ions that are present in water. You know very well, in our previous classes we have studied that calcium and magnesium and some other heavy metal ions, if they are present in water, they causes hardness. Okay, so zeolite is having sodium ion, and this sodium ion can easily exchange with the calcium and magnesium ions that is present in hard water. So in this way, if this exchange takes place, then our water could be softened, and this is the principle of zeolite process. Now the chemical structure of zeolite process is Na2O, Al2O3, X SiO2 and YH2, where the value of X ranges from 2 to 10 and the value of Y ranges from 2 to 6. Now if we go through the process, what happens in the process? For softening of water by this process, hard water is poured or percolated at a specified rate through the bed of zeolite. This zeolite bed is kept in a cylinder, and we pour water to this bed, the water which is to be softened. Okay. Now the hardness causing ions, you know very well, calcium and magnesium ions that are present in hard water are retained by the zeolite bed in the form of CaZe and MgZe, means calcium zeolite and magnesium zeolite, while the outgoing water, means the water that is coming out of the zeolite bed, contains the sodium salt. Okay, so what happened in the zeolite bed? The exchange of ions has took place. In place of calcium and magnesium, sodium ions will go in hard water, and the calcium and magnesium ions from the hard water is retained in zeolite bed. In this way, our water is softened. So a very simple and very effective process. Now let us see the reactions. Sodium zeolite, it is reacting with calcium bicarbonate. Calcium bicarbonate is present in hard water. In the same way, magnesium bicarbonate or calcium chloride or magnesium chloride, all the hardness causing ions that are present in hard water, when they are passed through zeolite bed, they form calcium zeolite, magnesium zeolite, and the sodium is exchanged, and this sodium comes in the softened water and it forms sodium bicarbonate or sodium chloride or sodium sulfate. So in this way our water is softened. You can see the diagram of zeolite bed, a very simple diagram, cylinder having zeolite in the middle, that is zeolite bed. When we pour hard water, it goes through the zeolite bed and exchange of ions takes place, and in the end we got the soft water. Now in this diagram you can see NaCl solution inlet is also seen, that we will discuss what is the role of this NaCl. This NaCl is used for regeneration of zeolite bed, because what happened, After some time, when the zeolite is completely converted into calcium and magnesium zeolite, then it has no capacity to soften the water, means it is exhausted. Now at this stage, we will stop the supply of hard water, and in place of hard water, we will supply 10% brine or NaCl solution. What will happen? Just a reverse reaction will take place, means calcium or magnesium zeolite will react with brine, again exchange of ion will take place, Na will be coming in the zeolite bed, and Ca and Mg will go out of the zeolite bed, and in this way we will recover the sodium zeolite again. So this is the regeneration of zeolite bed. So in this way the zeolite bed is regenerated. Now if we will come to, or we talk about the advantages of this process is very advantageous, very efficient, because in the end of this process we get softened water of about 10 ppm hardness, means residual hardness that is left after this process is 10 ppm. Now the second advantage, the equipment we have seen, it is very compact, very small, means it occupies very less space. Third advantage of this process is no impurities are precipitated, because in lime soda process we have seen lot amount of precipitates are formed, and lot mess is there in disposal of these precipitates, but here there is no precipitate formation, so very clean process. Now it is a quite clean process, and it requires less time for softening as compared to lime soda process, means it is a fast process. And another advantage is that it requires less skill for maintenance as well as for operation. Okay, now let us discuss some of the limitations of this process. One limitation is that if the water is turbid, if some impurities, if some suspended impurities are present in the water, then that impurity should be removed prior to the water that is to be poured in zeolite process. Okay, because it clogs the zeolite bed. Okay, so first we have to remove the turbidity, and then the water is used to be poured to zeolite. Then if colored ions are present in water, such as manganese ion or iron, then it also has to be removed very first, because it will cause very difficulty in regeneration of the zeolite bed. Another limitation is that if mineral acids are present in the water which is to be softened, so these minerals destroy our zeolite bed. Therefore, these mineral acids should be neutralized first with soda, and then the water is admitted to the zeolite softening plant. Okay, so these are the limitations of this process, but still this process is very advantageous, very efficient. Residual hardness is simply 10 ppm. So a best, we can say, a very good process to be used for softening the water. So this way we have discussed about the zeolite process, which is a water softening process. In our next class we will be discussing about some other water softening process. Till then, stay tuned and keep learning.